So today we're going to be talking about triangle similarity. In order for us to talk about triangle similarity, we must make sure that we recognize some of the conditions that need to be there for triangles to be similar. So two triangles are similar if they have corresponding congruent angles and if they have corresponding proportional sides. That means that there's a ratio relationship that is equivalent for both of these sides. So we're going to begin with a little scenario. I'm going to draw a little rock. There's this rock here. Somebody is standing here on top of this rock, okay? And on this rock, this person is able to measure this distance here that they have here, just like this, okay? So he's standing on the rock, and there's a river here. Cool. And what's given to him, and he was able to measure, is that using tape measure, he recognized that this was 8 feet. He also measured 6 feet. So he also measured that this here was 6 feet, and he measured that this tiny piece right here was 2.3 feet. So his goal was to figure out what was this distance across the river. That's what he wants to figure out. So we're going to call that distance across the river x, okay? So the first thing we have to do is make sure that these triangles are indeed similar. So we recognize I do have vertical angles here. When two lines intersect, opposite angles created are congruent and called vertical angles. So I know that right there. I also notice that this line and this line are parallel. So when parallel lines are cut by a transversal, alternate interior angles are congruent. And because triangle angle sum theorem says that all triangles sum up to 180, I know that if these two angles are corresponding and congruent on these two, then the third angle must also be. And in this situation, that third angle is a right angle. So I now have all the information. I do know, though, that from here to here is 8 feet. However, I just need it from here to here. So this difference between 8 and 2.3 is going to give me that distance. So 8 minus 2.3 gives me 5.7. So I know that this right here, just this right here, is 5.7 feet. So what I'm going to do is I'm going to recreate these triangles now, and I'm going to place them in a corresponding position. Okay, so I have that. I have the double congruency marking here and the single congruency marking here. This is what I want. I don't know what that is. I do know that this is 5.7. And then I'm going to draw the little one in corresponding position as well. So that means that the double marking here has to be on the top and the single marking is here. So remember that this side length here from the right angle to the single is 2.3 feet. And I'll put feet here too. And from the right angle to the double is 6 feet. So I now have my triangles sitting in corresponding, what would I call it? Perspectives. And I recognize that this right here corresponds to this guy here, as this corresponds to this over here. So that's why they're sitting in the same location. I'm now going to create a ratio for this. So the ratio is always going to go, this guy corresponds to this guy on the other one, as this one corresponds to this one on the other one. And so if I start with the bigger one to the little one, I also have to do that for the next relationship. So watch what I'm going to do. 5.7 is to 2.3. as, so 5.7 is to 2.3 as x is to 6. So that little proportional relationship is going to give me the missing value for x. When I have a fraction equals a fraction, I will cross multiply. So that gives me 2.3x is equal to 6 times 5.7, which is 34.2. So 6 times 5.7. So I get 2.3x equals 34.2. I'm going to divide both sides by 2.3. And that gives me 14.9. So divide both sides by 2.3. And that gives me x is equal to 14.9 feet. So that's what it gives me here. So that means that this distance across the river is 14.9 feet. And there you have it.